So what I want to do is cover a generic idea of what is surface area. Shh, I'm sorry, I'm talking. So we're in lesson chapter 8-4. We're going to specifically talk about surface area of a cylinder. Today's date is 5/16. Now, of the two shapes that we're going to cover, there is an easy way to do the cylinder, and there's not an easy way to do the cone. So it comes down to memorizing formulas. There is a formula for both of them. They are not the same formula because they're definitely not the same shape. They have elements that are similar because they both share the same idea of circles. And basically what you need to do is just memorize. One of the things I finished up the chapter 6 tests, and they've been put in and they've been published. And one thing that I noticed, the difference between the people who did well and the people who didn't, people who did well knew the patterns. So they realized, oh, if it's a rotation 90 degrees clockwise, that means the x's and y's swap places and the old x becomes negative. And so when they had those patterns down, it was really easy to figure out what the new coordinates would be. Some of you had some struggles with writing down what the correction or the directions asked. A lot of people didn't write down the new ordered pairs. They just drew things. And there was only one question that asked you just to draw and not list out coordinates. And so that was what kind of slowed down, was to trying to figure out. And then the worst part was your organization of information. Generally speaking, when you're labeling out coordinates, you're going in alphabetical order. And some of you just went in this random order. And oh my goodness, I was expecting things to be given in a linear fashion, so alphabetically. And so all of a sudden I'm like, whoa. And it literally, it's like my brain comes to a crashing halt. And I have to whoop, back up, and then I have to go, okay, hunt and peck, and it slowed me down tremendously. So always think about when you are presenting information, you should be presenting it in a logical fashion, not a willy-nilly fashion. So if you've got things that are alphabetical, list them alphabetical, and that's going to make it easier. Dylan, you don't need to do that anymore, okay? So let's talk about surface area in general, and then we'll talk about it specifically for a cylinder. So in general, surface area is simply the sum of all surfaces, or let's see, let me try that again. Sum of areas of all surfaces of a solid. And remember, solid is a fancy way of saying, or actually it's a short way of saying three-dimensional object, okay? So this also has a secondary name. Some people call it total surface area. In my geometry book, they called it total area, and it used an abbreviation of TA. So there's all sorts of different ways, but when you're talking about surface area, it's talking about the area of the surface of your shape, okay? Now, what's different than regular area is that we have sides to these solids. And that's not what we're used to. We're just used to flat things, and so that complicates it. So there's a generic name for what those sides are called, and that's dealing with lateral area. Does anyone know where their latissimus dorsi, their lats, are on their body? It's a big muscle group. Okay, they're right here on your sides. They kind of fan out from your back. People who do swimming tend to have that really cut V, and it's back here that you see those muscles coming through. So they are on the sides, and that's what lateral area means. It's the area of the sides, okay? So it is the area of the side, and I'm going to put in parentheses an S, of a solid. And the reason why I do that is when we looked at, in the past, you've looked at prisms and you've looked at pyramids. Well, with prisms and pyramids, you had specific shaped sides. So in general, on the prism, you had rectangular or square sides. So if it was a rectangular prism, you would have 4 rectangular sides. If you had a cube, you would have 4 square sides. If you had a triangular prism, you would have 3 rectangular sides, okay? Now, with pyramids, they're like a cone in that they come to a point, but they have a flat base. They're different from a cone because the base is not a circle, so it has all squared edges. So a square pyramid has a base that's a square, and then all of those sides go up to a point. So if you've got a flat bottom and a pointy top, what shape would you be? I heard somebody say it. Yeah, think about the pyramids. All the sides are triangles. You have triangular sides. Where we come into a problem with the 2 shapes that we're going to discuss, the cylinder and the cone, how are they different from the regular prisms and the regular pyramids? What's their biggest difference? Yeah, they've got a curve to them of some sort. So cones and cylinders they have curved sides. Okay, so that's where we come into a bit of an issue trying to figure out, we can't just look at it and figure out what shape it is. So what we're going to do is something called a net. Have you guys worked with nets before? Who can explain to me what do I mean by a net when it comes to these 3-dimensional objects? Savannah.
Like when you open up a cereal box completely, like when you take all the box apart, and you lay it out flat.
So it's basically taking a 3-dimensional shape and cutting it down a side and opening it up and looking at all the flat surfaces, but they're all connected, okay? So it's a, let's see how to write that in words, a 2-dimensional version of a 3-dimensional shape. You lay out flat the sides of your shape. So Savannah mentioned like a cereal box. Now the hard part is we've got things that are behind when we're looking at a cereal box. So if I cut the cereal box, and let's say I would cut, how do I want to cut this? I probably would cut around those 3 surfaces. I would then probably cut here and here, and then I would probably have to cut around those 3 surfaces. So when I did that and I laid it out flat, you've got a front, you've got a back, so here's your front, here's your back. This is the bottom of the box. and you're going to have a flap up here for the top of your box. And then attached to one of, because we're cutting things apart, attached to the sides, either to the front or to the back. This would be the sides. Now I'm grossly doing this out of proportion. And you end up with a total of 6 rectangles. And then your job would be, if you knew the 3 dimensions of this, you would label each of the rectangles with the dimensions, and then you could figure out the area of each rectangle and then add them all up. Okay, because total is what we're looking for surface area, so we'd add up all of those. So this is a 2-dimensional version of a 3-dimensional shape. Okay, so that's kind of the generic. Let's get into the specifics. Today we're just going to talk about the cylinder. Is everybody good? So what do you think the net of a cylinder would look like? So to help you, I'm going to bring you a cylinder. So here's my little cylinder. You can see what the top and the bottom are. You can see that the side is curved, but my hope is to open this up. So what do you think I'm going to see when I open this up and lay it down flat? Susie? Okay, so what we're going to do is I'm going to draw my picture of how it looks. The 2 key pieces are a radius and a height. So when I open this up, Susie's absolutely right, and I can open up my little guy here. We've got a circle. We've got another circle. I did my tape too well. And we have a rectangle. Okay? That's so pretty. So we still have a radius, and we still have a height. And, nope, that's the wrong way. Height goes the other way. This is your height. Because I took my shape and I took it from here and then I put it this direction. So if this is the height, my problem is what's the long side of that rectangle? So think about where it was before. I'll close it back up. And what would you describe? Oh, come on. The long side. Remember where the long side comes from, okay? Oh, I'm hearing Savannah. Savannah, you're hot today on this. This is awesome. So the circle comes down. I open up. And the long side was what went around the circle. So the long side is actually the circumference of the circle. Okay? So let's write that down. C is circumference. And we have actually 2 versions of this. But since our cylinder formula for volume used radius, we're going to focus just on the radius version. So what's the radius version of a formula for circumference? What does C equal if I'm basing it just on the radius? Oh, come on, this is a basic formula you guys should have memorized since 5th grade. Nope, that's the area of a circle. Right now I'm just looking at circumference of a circle. Okay? You're jumping on the gun. I'm looking here. I want to describe this long side of my triangle, this green long side, so from here to here. So that's the circumference of the circle. What's the formula for the circumference of a circle using radius? Susie? 2 pi r. All right, so our circle, or our cylinder, is composed of our net, 2 circles, and 1 rectangle. We need to figure out for surface area the area of each of these. So now, what is the formula for the area of a circle?
Pi r squared.
That one is the pi r squared. But how many circles do I have?
2.
2. So I'm going to write for this portion
Pi 2 squared.
2 pi r squared. That is for the 2 circles. So the area of the 2 circles would be represented by 2 pi r. Now the rectangle, it's made up of, how do we figure out the area of a rectangle? Okay, length times width. And so for this one, we've got circumference times height. Okay, well, what did we say circumference was the same as? What's the formula for circumference of a circle? It's written up there. What's it say?
2 pi r.
It says 2 pi r. So if we put those together, 2 pi r to represent the circumference and h to represent the height, so there's our length and our width, this would be represented by 2 pi r h. So basically, the formula for the surface area of a cylinder is the sum of those two together. So this is the first formula. Sorry. No. So the surface area of a cylinder is equal to the area of the 2 circles and I'm going to say 2 bases plus the 2 pi r h, which is the area of the lateral side. So lateral side is kind of a repetition there. And that's what it is. So you have 2 ways to solve this problem. Is number 1, memorize the formula and plug numbers in. Or number 2, draw out the net of your cylinder, figure out the circumference, which is the length of the rectangle, and figure out the area of the circle, double it, figure out the area of the rectangle, and add those 2 together. So those are kind of your 2 choices that you get to do. Okay. Now, the area of the lateral side has a different name, so just so that you'll be familiar with it. This is called the lateral area. Is that 2 pi r h is the area of that lateral side. Okay, side. Okay. Now, what's weird is when I cut this open, it didn't look curved anymore, other than the circles, which we expect a circle to be curved. But the cylinder is very special, and you can prove it to yourself by going home, ask mom or dad, okay, what are you guys going to make for dinner tonight? Does it involve a can of something? And if their answer is yes, and that can has a label, say, can I take the label off, please? And if you take the label off, you're going to discover, whoop, there's that rectangle. It really is true, okay? So we've got a couple of examples we want to do. Directions are going to be find the surface area, of the cylinder, round to the nearest tenth. So same directions, basically, as we did with volume. And yes, you're allowed to use a calculator on this, okay? So we're going to do the same thing we did before. We won't have a button for pi, so we're going to use pi as our 3.14159. Okay. So here's our cylinder, our first one. They're going to give us a radius, and it's 2 centimeters, and they're going to give us a height, 7 centimeters. So the easiest thing for me is formulas. So I'm going to use symbols. Surface area is just going to be SA. Equals, and then the formula says we have 2 circles. The area of each circle is pi r squared, so we get 2 pi r squared. Then we get a rectangle, and its dimensions are the circumference of the circle times the height, and circumference of a circle is 2 pi r times the height. So we're going to put in our identified pieces of information where we've got 2 as our radius, and we're going to square that, and we're going to add to that 2 pi, and again 2 is our radius, and our height is 7. Now here's what I expect that you can do. Because both of these are going to involve pi, this is what I need to see to be called complete work. Well, this gives me 2 pi 4, this gives me 2 pi 14, that gives me 8 pi and 28 pi. And because they both are in terms of pi, all I'm going to do is take the coefficient numbers, the 8 and the 28, and I'm going to add them together. So that gives me 36 and then pi. And then I take out my calculator. All right, so I have 36, and this is again what I'm putting in the calculator, times 3.14159. So 36 times 3.14159, and we get 113.09. And at that point, that's as far as I really need to write it down. It goes further, but all I care about is the tenths and the hundredths. Okay? And 9 is going to take that 0 and round it up. So my answer would be approximately 113.1. Now, because this is an area, what should my label look like? Single label, squared label, cube label. Area. What do I do to my label? I square it. So all area labels are squared. Okay, so make sure you remember that. I saw a lot of people wrote squared areas on volume. Volume is cubed. Okay, so you got to remember that. So that would be your answer. All right, let's try another one. Let's do one that looks like this. Shh. So this is 14 meters, and this is 10 meters. So again, what you can do is you could look at it as the net. And if we did it as a net, you would have a circle. Oops, here, let's do this again. Let's do it this way. The lateral side, and then we have the 2 circles. I'm going to fill in the information that it told me. And remember our formulas, our areas for circles, that's only given in terms of radius, so we are going to have to change our diameter into a radius by taking the diameter and cutting it in half. So that would give us a radius of 7 meters for each of these. What butts up next to the circles is a circumference, because that's what wraps around our circles. And we're going to get for circumference 2 pi r. And then the height was given to us, and it was the 10. So I could figure out this via the net, and I would have surface area would be equal to the area of a circle plus the area of the rectangle, which would be the 2 pi r times the height, plus the area of the circle. So it's the same formula, it's just kind of split up in two different pieces. And it makes a little bit more sense to say, well, I've got 2 circles, so why do out the math separately? Why not just take it once and then double the answer? So we're going to get pi 7 squared, and then I notice there's 2 of them. Okay? And then the circumference is the 2 pi r, so that piece is 2 pi, and the radius is 7. And then we're going to multiply that by the height, which is 10. So then I just start doing math. And I get 49 pi times 2 plus 14 pi times 10. 49 times 2, let's see, that's going to give me 98 pi. And 14 times 10 is 140 pi. And when I add the numbers together, 98 and 140, I get an 8, I get a 13, and I get a 238 pi. And then I use my calculator. So again, we are using 3.14159. So I have 238 times 3.14159. And I get 747.69, and this is as far as I need to go. And I'm going to round to the nearest tenth. So 9 is definitely large enough to bump up the 6 to a 7, and I would say 747.7, and what label would I add to this answer? What squared? Yeah, square meters. Okay. All right, I've got one more. It's a word problem, and then we'll be done. Everybody good here? Okay. So unfortunately, we do have to write down the words. Say, a circular fence is 2 feet high. It is to be built around a carousel. Merry-go-round. The distance from the center of the carousel to the edge of the fence will be 35 feet. What is the area of the fencing material that is needed to make the fence around the carousel? So the question is the question asking us to find the area or surface area of a cylinder? Are we building a fence so that it goes around and it has a fence on the top and has a fence underneath it? No. So we're not using the surface area formula. What is it that we're actually figuring out the area of? Top, bottom, sides. Side. Okay, so that's just lateral area. So this particular one, all we're figuring out is the lateral area. So that's part of word problems, is that they don't always tell you exactly what you're looking for. You need to visualize it in context with what we've been learning and realize it's not the whole thing, because there isn't a fence on the top and there isn't a fence on the bottom. So we don't have circular parts on the top and bottom to deal with. So they're asking for, what is the lateral area? So the lateral area, remember, is just that rectangle. That rectangle, the curved part, is actually the circumference of a circle. And then the height is our height. So we basically take our fence and we're looking at this piece, right? Because again, we don't have a top, we don't have a bottom. And so this is the lateral area. So we're just looking at the circumference of the circle times the height. So let's see if we can identify what are those two pieces of information from this particular problem. Did it tell me how tall the fencing is? Yeah, it said it's 2 feet high. So we know that H is the 2 feet. Okay. Does it tell us as the distance from the center of the carousel to the edge of the fence will be 35 feet? So what does that 35 represent? Yeah, from the center to the edge is called a radius. So they gave us radius is 35 feet. So now all we do is plug numbers into the formula and we solve. So we have 2 pi, we have the radius is 2, and the height is 35. Oh, I did, didn't I? You know what? That's so funny. In this particular case, does it make a difference? Not in this particular case. It would make a big, huge difference if we had to make a circular top and a circular bottom. Thank you for catching that. So our radius is 35 and our height is 2. And by the way, I'm thinking a 2-foot height over carousel. 2-foot height is like nothing. What were they thinking? Is that just so little kids can't, I don't know, the little kids could scramble over a 2-foot fence. I mean, infants, no, but infants wouldn't be riding a carousel without their parents. That's weird. Anyway, we'll just go on. So we've got 2 times 2 is 4, and we have a pi, and we have a 35. 4 times 35 is going to give me, 4 times 5 is 20, carry the 2, 4 times 3 is 12, plus 2 is 14. So I get 140 pi. And this is when I use my calculator, and I multiply 140 times 3.14159. And I get 439.82. Now, how many of you ever gone shopping with mom or dad in a lumber store and you had to buy something, wood of some sort? Do you get to buy 439.82? No. Do you buy that exact amount of fencing? No. You usually have to buy it by the foot, and you want to buy a little bit extra because of the fact that there could be a bad board and you want to replace it. But for our purposes, we're just going to keep following the same process, and we're going to take that answer, we're going to round it to the nearest tenth. So I've got an 8 followed by a 2. 2 is certainly not big enough to round that 8. So we would say about 439.8, and then let's see, what's our label in? No, remember it's area, so it's not cubic. So it would be about 439.8 square feet of fencing is needed. No, is. So word problem, word answer. Okay, and a complete answer would have said what is needed to be built around the carousel. Okay, so that's what you guys are working on today.